All right, challengers, welcome. We are now beginning chapter 14, square roots, Pythagorean theorem, exponents, things like that. So the actual lesson is called, or the actual chapter I should say is called Real Numbers and the Pythagorean Theorem. Pretty exciting. So first, finding square roots. So first, what is a square root? Well, a square, obviously you can see the square, right? A square root is you're looking for the side length of a square if someone tells you the area. So for example, if you say an area is 49, the area of a square is 49, then you need to find the two side lengths. So remember, all four sides of a square are the same. So we're looking for two numbers, which is the same number that multiplies to 49. So 7 and 7. So the square root of 49 would be 7 because 7 times 7 is 49. So what is a square root? Well, that is a square root sign. We call that a radical. That's going to be really popular. You're going to put the number inside. So the number inside is actually called the radicand. We don't really use that too much. I'm just going to say the square root sign, but it's technically called a radicand. Now, that square root sign, since it's a radical, it's not always a square root. It could be a cube root, a fourth root, a fifth root. So there's always a number right there, and that's called the index. Now, if there is no number, that means we're taking a square root. But if we want to take the cube root, we would put a 3 there. At the fourth root, we would put a 4. But if there's nothing there, it's just a 2. It's kind of like 5 to the first power. We don't really put the first power, right? We leave it blank, right? Just like 5 is really 5 times 1, or 5 to the first power. We don't put that stuff, right? Or like the variable x. We don't put 1x, but we do put a 2x, a 3x, a 4x. It's the same thing with the index. It's invisible if it's a 2. So this is just square root of 49. So as we said, square root of 49 is 7. Not magic, guys. It's just a square root. You're picking the number that you would multiply with that number together to get to the original number. So 7 times 7 is 49. All right, for example 1, we're going to find these square roots. All right, let me go ahead and freeze the screen. So to find the square roots, we want to look for a number that multiplies up to 25. So one way to do that is to break down 25. So to break down 25, what we're going to do, we're going to have our 25 and we're going to break it down. Well, this only breaks down to 5 and 5. So look at that, 5 and 5. So the square root of 25 is just 5. For square root of 169, we're going to break that down. Well, there's only two numbers that multiply to 169. That's 13 and 13. So the square root of 169 equals 13. But we have that negative in front. So our answer would be 13, but then we have to put that negative in front. So our answer is negative 13, right? Plus or minus, okay. Now 144. What two numbers multiply to 144? Well, 12 and 12. So technically, we're done, right? But if you want to go a little bit further, and I'll show you something different, and then you could do 4 times 3, and then 4 times 3, and then this breaks up to 2 and 2, and 2 and 2. So our prime numbers are 2, 2, 2, 2, 4, and 3. And you want to find things, oh, not 4, not the 4, sorry. 2, 2, 3, 2, 2, 3. So you want to find things that match. Well, look, there's 4 2s, and there's 2 3s. So you can match up a 2, a 2, a 3, and a 2, a 2, and a 3. Well, 3 times 2 is 6, times 2 is 12, and 12. So that's how you get your answers of 12. But just remember, square root of 144 is 12, because 12 times 12 is 144. A lot easier, right? And then you have a plus minus in front. So that's your answer. Last one, square root of 1. Well, what number multiplies the 1? 1 times 1, right? So that means we would end up with 1, or absolute value, and then square root of 1, well, we can take out that square root, right? Because we found the value of that. Square root of 1 is just 1. So we have absolute value of negative 1. Well, what is the absolute value of negative 1? It's just 1. And we're done. It's not too difficult, guys. Let's go ahead and do a couple more examples. A little bit trickier, right? So now, square root of 0.25. Well, that's kind of like 25, right? So if you want to find the square root of 0.25, think about it. Try to find the square root of 25. Well, 5 times 5 is 25, right? So that means let's just use 0.5 instead. So if I do 25, that's 5 and 5, right? But we need 2 decimal places over, so we're going to say 0.5. And that's your answer. 0.5. Here, I'll make that a little bit clearer. 0.5 is your answer. For B, negative 0.0009. Well, let's find the square root of 9. So that's 3 times 3, which equals 9. But we need 4 decimals, which means we need 2 decimals for one 3, 2 decimals for another 3. So instead, we're going to do 0.03 and 0.03. And that multiplies to 0.0009. So we're going to do 0.03 as our answer. But then we have this negative, so we need to put the negative in front. All right, next, plus or minus 1 over 9. Now, with a fraction, you need to take the square root of both the top and the bottom. So I'm going to rewrite this as plus or minus square root of 1 over square root of 9. And that's going to equal plus or minus square root of 1 is just 1. Square root of 9 is 3, like we talked about. So plus or minus 1 over 3. And think about it. 1 over 3 times 1 over 3 equals 1 over 9. That's why we split it up, because we do the 2 ones on the top and we do the 2 ones on the bottom. All right, last one, negative rad 25 over 36. So we're going to do rad 25 over rad 36. Well, square root of 25 is 5 times 5, so we get 5. And 36, 6 times 6 is 36, so you get 5 over 6. And you just move that negative down, so it's negative 5 over 6. Hopefully this is kind of making sense. I know square roots are a little bit new, but they're really easy once you get used to it, right? You just find the number, your perfect number that you multiply by itself to get your answer. All right, The area, moving way too ahead. The area of a circular pie is 225 pi square centimeters. What is the diameter of the pie? So when we do this, first we need to find the area of a circle, right? What is the formula for the area of a circle? So first, let me go ahead and draw a circle, and then we'll write the formula, and then we can go ahead and do this. So I'm going to draw a circle, right? So how do you find the area of that? Well, if you guys remember, area equals pi r squared, right? But what is the area of this? We already are given what the area is. It says the area of the pie is 225 square centimeters. So I'm going to put in here 225 pi. Therefore, our formula 225 has to equal, 225 pi. Let me make sure that pi part is really important. 225 pi has to equal pi r squared. Does that make sense? Because the area has to equal area, right? We skipped the formula because it just gave us the answer, but now we're going to use the formula. So 225 pi has to equal pi r squared. And now we're going to simplify some things. For example, we're going to divide both sides by pi. When we divide both sides by pi, these cancel out, and then I'm going to flip it at the same time. So that means r squared equals 225. Now, this is the part that's new. I'm going to move this to up here. Now, how do you get rid of an exponent? Well, think about it. 7 squared equals 49, right? So what if I took the square root of both sides? Taking the square root's like an operation. Whatever you do to one side, you have to do to the other. So taking the square root of 7 squared. Notice here, I can cancel out a square and a square root, and I get 7. Now, what's the square root of 49? 7. So it works. So taking a square root cancels out an exponent. So I'm going to take the square root of both sides. Square root of both sides. Now, these cancel out. So R equals rad 225. Well, now we just need to figure out what times what equals 225. Well, your answer is 15. So the radius equals 15 centimeters. You're done, right? No, you are not done. It says, what is the diameter? So if the radius is 15, the diameter equals 30 centimeters. Don't get tripped up on that last part. All right. Last problem for the first section is going to be, these two examples. Remember, certain orders matter, right? So one thing that matters, PEMDAS. Remember, please excuse my dear Aunt Sally. I'm sure a lot of you guys have heard that before. Maybe you guys haven't used it as much, but parentheses come first, and then exponents, multiplication, division, addition, and subtraction last. So as soon as this loads, then we'll go ahead and do the example. All right, so first, parentheses. So inside the rad 36. So what is the square root of 36? 6. So we have 6 squared plus 12. So we did parentheses. Now we need to do exponents. Well, look, 6 squared. 6 times 6 is 36. 36 plus 12, there is no multiplication division, so we do addition and subtraction. 36 plus 12, 48 is your answer. Done. For this second one, don't do 10 minus 5 and put 5. Try to be a hero. Don't do that. Wrong, right? Because you need to first do parentheses and exponents. So that's 10 minus 5. Well, what's the square root of 9? It's 3. So we have 3 squared. Don't do 10 minus 5 yet. Do 10 minus 5 times the exponent. 3 squared. 3 squared is 9. So we get 10 minus 5 times 9. And then, again, don't do 10 minus 5. That's last. You do 5 times 9. So you get 10 minus 5 times 9 is 45. So 10 minus 45. And then your final answer is negative 35. Hopefully that makes sense. So we're done. Your homework due Friday, 5/8. I believe that's the correct date. Yep. 11:59, 14.1. It's 4 through 32 evens. It's pretty easy, guys. So good luck on your homework. Make sure you guys get that in by Friday, and you guys have a great rest of your day. All right. I will talk to you guys later, challengers. Bye.